I'm going to show you how to solve the Ethernaut challenges. In this video, I'll tackle the first challenge, Fallback. So I'll scroll down and then let's see what the objectives are. The objectives are to claim ownership of the contract and reduce the balance to 0. If I scroll down further, this is the contract that we'll need to hack. So I'll copy this contract and then I'll paste it over to Remix. But before we do that, we'll get the instance by clicking on the button Get New Instance. This will deploy the contract above. While we wait, I'll head over to Remix and then paste this code. Inside Remix, I pasted our objectives and the contract that we'll need to hack. Now notice that the first objective says that you need to claim the ownership of the contract. This means that if we try to hack this contract using another contract, then we'll fail the challenge. I learned this the hard way. So what we'll have to do is analyze the contract and then manually call the functions inside this contract, and we'll have to take ownership of this contract. So let's take a look at the contract. Let's take a look at the first objective. How do we claim the ownership of the contract? So I'll highlight the owner state variable, scroll down, and I'm looking for places where the owner is set. I see that the owner is set over here, and if I scroll down further, I can see here that the owner is set to message.sender. And the way we can trigger this part of the code is by satisfying this condition. It says that we'll need to send some amount of Ether and contributions of message.sender has to be greater than 0. So how do we set contributions to greater than 0? I'll highlight the contributions, state variable, and scroll up. And I see over here that if we call the function contribute, then we'll be able to set the contributions of message.sender to some number greater than 0. So what we're going to do is call the function contribute. And then next we'll call the function receive. And this will set the owner of the contract to us. And lastly, once we're owner of this contract, we'll be able to call the function withdraw and withdraw all of the Ether from this contract. Again, to win this challenge, we cannot deploy a contract that does this. We'll have to manually call the functions on this contract and then claim the ownership from our wallet. So let's load this contract into Remix. So to get the address of the contract that is deployed, I'll click on F12 and then type contract.address. This is the address of the contract that was just deployed. I'll copy this. And then inside Remix, I'll click on the Deploy and Run Transactions tab. And then we'll load the fallback at the address that we just copied over. But before we do that, I'll make sure that I clicked on the provider for injected provider. And this will load our MetaMask that is connected to the Goerli testnet. And then I'll load the fallback contract at this address. And then open it. So again, first thing we need to do is call contribute, sending some ETH. So I'll send one way of ETH and then call contribute, confirm the transaction. And once the transaction is successful, the next function that we'll need to call is receive. Notice here that we don't have a way to call receive. So what we'll have to do is call the low-level interaction transact with empty data. And again, we'll have to send some ETH. So again, I'll send one way and then call transact. Hit confirm. Okay, once that transaction is successful, let's check that the owner is set to us. So I'll click on the owner state variable, and that is the address of my wallet. So we are now the owner of this fallback contract, and we can lastly call the function withdraw. Okay, the transaction was successful, so now we completed both the objectives to claim the ownership of the contract and withdraw all of the ETH from it. The last step is to go back to Ethernaut and then click on Submit Instance. And then click on Confirm. Once you win the challenge, you'll see a button that says Go to Next Level. So we completed this level. See you in the next level.